I've been programming for quite a while. I first started with BASIC on the Timex Sinclair 1000 computer I received as a gift from my parents for Christmas in 1982. Coincidentally, also my 17th birthday. It was super awesome and was even purchased with a thermal printer and 16 kilobits memory expansion pack. The rest they say is history. Or more to the point, my future. The first program I wrote in Sinclair BASIC was tic-tac-toe, which I didn't so much as write, but copy out of a programming magazine I ordered through the mail. That same year my father's small print shop purchased a Zenith Z100 personal computer that I used to automate the accounting system, and I had a chance to take some computer math classes in high school that used the school's TRS-80 lab and a Wang 2200 mini computer that ran from Mark-Sense cards. Later in my junior and senior years, I was able to take classes that taught Fortran and Pascal on the shiny new IBM 88 PCs and COBOL on the local college's IBM mainframe using our school's card punching machine. In college, I took courses in Fortran and Pascal that ran on the PC and the new IBM PS2s, along with applications on the university's IBM 370. In my analog and digital electronics courses we learned interfacing between chip-level UARTs, counters and 88 chips using assembly. Later in my senior seminar course we created computer-controlled instrumentation using Commodore BASIC on a Commodore 64. After graduating with a Bachelor of Science degree with a double major in chemistry and physics, I developed a quotation program in Borland Quick BASIC for the print shop over the summer before entering graduate school at The Ohio State University. In grad school I used a dialect of 4th under MS-DOS on an IBM PC386 to develop the control, data acquisition and data analysis software for a new ultra-fast laser spectrometer created by our research group. After graduation in 1992 with my PhD in analytical chemistry, I worked for an on-site defense contractor for the U.S. Air Force at Wright-Patterson Air Force Base, developing new laser-based diagnostic systems for the study of fuel stability and combustion research, as well as wind tunnel measurements for airframes and turbofan jet engines. I created system and data analysis software in ANSI using the log Windows CVI development system from National Instruments. In 1999 I left industry to accept a faculty position at LaSalle University to assist in the development of the Integrated Science, Business and Technologies BIT program. I used National Instruments LabVIEW to teach our undergraduates the fundamentals of application programming, data acquisition and analysis, laboratory informatics, artificial intelligence and data mining. Things have changed a bit in the succeeding 12 years. One major change is the prevalence of mobile computing. The BIT program issued Compaq iPAQ personal digital assistant handheld computers in the fall of 2001. We expected that eventually professionals would need to carry small computers around to access their growing collection of personal data. While our students looked a bit conspicuous, we soon set up our university's first wireless Wi-Fi laboratory. With the introduction of Apple iPhone in 2007 we discontinued the program as almost all of our students arrived as freshmen carrying smartphones. The BIT program also worked with our university's IT department in April 2006 to host the school's first installation of MediaWiki so our majors could learn what it means to work in the cloud. We also experimented with grid computing starting in 2001 and eventually donated a total of 76 years, 323 days, 13 hours, 8 minutes and 51 seconds of computational time to the Grid.org program administered by United Devices until that program's conclusion in April 2007. In early 2010, BIT was a beta participant in the National Instruments Web LabVIEW project, which developed a cloud version of their award-winning graphical development environment that runs in a browser and utilizes Silverlight. Things have been progressing along nicely with evolutionary improvements in versions of development languages and operating systems. Until Google this week made some major announcements. Android Gingerbread 2.3 and the Nexus S phone. Google eBook service. Chrome Web Store. Chrome OS. Chrome OS Cr48 notebook. Wow! 5 rapid-fire revolutionary technology announcements. It's a good thing it's close to Christmas, otherwise I'm not sure how well our shocked systems could handle such great news. I've been thinking about which programming language environment should be next on my list to learn. Java has been on the radar for a while, not the least of which, Java is the language used to program the LiveScribe smart pens which replaced our ISP PDA program. Java also is the language needed to program for Android. But this week's announcement of the Chrome web apps has pointed the way to HTML5. Or more completely, HTML5, JavaScript and CSS. The tools needed to develop Chrome web apps. As our students head to the cloud using Gmail, Google Apps and others such as XtraNormal used here, migrating to a Chrome OS Cloud notebook is definitely in our future. I would be delighted to have the chance to offer feedback to the development program by participating in the Chrome OS Cr48 Notebook Test Drive program.